Okay, just to the Professor, Dr. Dolphy Gilpin, and we have returned with our Californium. We're looking at Californium, the properties, the reaction, its availability in nature, and its uses. So we had said that Californium, the price, $27 million per gram, as compared to gold, $34 per gram. And Californium is produced by bombarding. This is one of the methods, curium, with alpha particles in a nuclear reactor. This is just one of the methods. And later on, we're going to be showing you a lot of other ways that Californium is made. But here we are saying that it is produced by bombarding curium with alpha particles in a nuclear reactor. All right, let's look at our first reaction here with Californium. We have Californium plus oxygen. Yeah, we get reaction with that. And Californium reacts slowly with oxygen and the air. You know, air is a mixture of oxygen, nitrogen, hydrogen, and some noble gases. But we look at oxygen, nitrogen, and we look at it and hydrogen. And the group of oxygen here, the chalcogens. Okay, Californium reacts slowly with oxygen and air and tarnishes at room temperature. So it does tarnish at room temperature. Remember now, there's not much Californium available, as it's very expensive and rare, and it is synthetically produced. The most common oxidation state of Californium is +3. Chemically, Californium-98, that is Californium atomic number, resembles this dysprosium. That is dysprosium with a symbol dy, and other elements of the actinide series. That is, it resembles them in appearance and reaction. Most of them are silver white metal. And most of them also have a +3 oxidation state. Now, Californium-98 is a silvery white radioactive element which readily reacts with air and water. It readily reacts with air and water. It's a moderate reactive element. It also reacts with acids, but not with bases. So here are some reactions. Now we have Californium plus hydrogen. We have Californium plus nitrogen. We also have reaction with that. And we have Californium plus oxygen and other chalcogens. And you have to eat this now. Californium plus hydrogen, eat. Then we have reaction. Californium plus nitrogen. We get some complexes of Californium nitride, Californium hydride, and Californium oxide. Now, Californium reacts with water and other members of the chalcogens. Yeah, that's full stop. It reacts with oxygen and other members of the chalcogen. The chalcogen is that group that contains oxygen. Let's look at it. So it was group 16, and it will have sulfur, selenium, tellurium, what's that? Polonium, and livernium, LV. So that's the group there with oxygen, the chalcogens. So it's capable of spontaneous reactions when exposed to air. That is, it is flammable. But it's not explosively flammable, but moderately flammable and moderately reactive. All right, let's take another page here. Californium is magnetic, and its magnetism depends on heat. It varies directly proportional to the temperature. That means if you increase the temperature, what you're going to get is an increase in the magnetism of californium. And also, by varying the temperature, you could get other properties, like it becomes anti-magnetic, and it also could give you a paramagnetic property as well. That's by varying the temperature. But in general, by increasing the temperature, you get the magnetism is increased. All right, we're going to take California in three goes. So once again, as we cool off, Californium, atomic number 98, atomic mass 251, electronic configuration, radon, (5F10, 7S2, and we'll return with our Californium here.